Hello and welcome to How Do IBI, a mini-part screencast series on SQL Server Analysis Services 2008, which is based on my book Smart Business Intelligence Solutions with Microsoft SQL Server 2008. I'm Lynn Langett, Developer Evangelist with Microsoft in Southern California. And in this edition, we're going to talk about how to implement cross-validation to understand the value of the results of various mining models that you've created using BIDs. Before we go to the screencast, I've got a couple FAQs and gotchas. The first FAQ is that cross-validation does not require holdout data. The reason for this is because the data that's being processed is separated or folded and then evaluated across itself. So you're not required to provide holdout or sample data when you use the cross-validation method. Cross-validation is new in SQL Server 2008. A gotcha around cross-validation is that it has very, very high overhead. In order to make this more effective, you can adjust some of the parameters, in particular the fold count, and we'll see some of the other parameters in the screencast. Also, it's important to understand that cross-validation does not work with certain types of algorithms. The reason for this is because those algorithms are series dependent, and cross-validation separates, sorts, and processes without respect to those series. And an example of that would be time series data. So now let's go ahead and take a look at how this process works in the screencast. We'll be looking at a new data mining model evaluation technique included in SQL Server 2008 called cross-validation. In order to do this, I've opened BIDS and loaded the sample AdventureWorks, and I've opened the sample mining structure called targeted mailing. You may remember or know from previous screencasts or your own review that the mining structure targeted mailing includes multiple mining models and is a very good sample to use when looking at evaluating the effectiveness of various data mining models that are contained in the structure. To do this, I'm going to click on the mining accuracy chart, and you'll see that there are 4 separate tabs. Now, to implement other types of mining accuracy evaluation, the lift chart, the profit chart, and the classification matrix, you have to follow a technique that I've detailed in previous screencasts, and that includes selecting the mining models, the predictable column name, the predicted value, associating a data set to be used for the accuracy charts, and optionally specifying a filter for that data set. Cross-validation works a little bit differently. I'm going to click on that tab so that we can get started taking a look. Cross-validation does not require holdout or training data because cross-validation simply folds or separates and processes subsets of the input data mining model data sets without the need for the holdout data. Now you'll note in this dialog box that there are several parameters, and it's important to understand what these parameters do and how they affect the overhead of cross-validation. The first parameter is fold count. If I click on the drop-down box here, you'll see that the fold count is by default set to 10. The higher the fold count, the longer the processing time. Target attribute is set to the predicted value, which is bike buyer, and that's the only value that's available here. The maximum cases is a threshold for the number of cases in order to produce a result. The target state is the state for the particular attribute, and that state could have a threshold. For example, for bike buyer, we have 0 or 1. However, for a target state that has something more granular, we could have a threshold value or a level. Now notice it says right in the interface, to perform cross-validation, select parameters and click Get Results. Cross-validation might take some time, especially on large data sets where many partitions are tested. And in fact, oftentimes I'm finding, even working with the sample, that cross-validation will time out. So I'm going to go ahead and adjust the fold count to something a lot lower, to 3, and the maximum cases to 3. And now I'm going to click on Get Results. And it's going to take a couple of seconds to process this information, if not even a minute. So what is happening at this point is the analysis services server is being queried, and then the information is being processed using the fold count quantity and the max cases quantity. Now you can see in the results that we have a box for each of the included algorithms. So TM decision tree, I'm scrolling down here, TM clustering, TM naive Bayes, and TM neural net. And inside of there, there's additional information about the partitions, the type of test, classification, likelihood are the test types, the measure, whether it's passed or failed, and the value. So in order to have an understanding of the output of the results, you're probably going to want to consult books online if you're not familiar with the cross-validation techniques. Um, and you can see that they include very sophisticated deviations, log scores, root mean square errors, so on and so forth. Um, what I have found in working with this is that particular customers who have a background in statistics are interested in this information, but for most customers, the more classic validation techniques of using the lift chart and the profit chart are adequate. The other consideration is the overhead. We perform this cross-validation on a relatively small data set. I set the fold count to a relatively low number and the max cases to a higher number. And in working with this several times using the defaults, it did time out. So those are some considerations to be aware of when using cross-validation to look at the results of data mining models in bids. Thank you.